Hello, so today I'm going to go over steps to finding the interquartile range. So the interquartile range a lot of times is abbreviated by saying IQR. So here we have a dot plot that shows the top speeds of 12 sports cars. And we're going to find and interpret the interquartile range of my data set. So there are several steps involved when I'm finding the interquartile range, and I have them all listed here for you. Step 1, put the data in order from least to greatest. So when I look at my top speeds of my sports cars up here, the lowest speed is 220. So and there's only one of those, according to my dot plot, there's only one car that can go 220 miles per hour. Then 230, oh, sorry. And there's two above 230. So I have two cars that can go 230 miles per hour. No cars can go 235. I have two cars that can go 240 miles per hour. I have one car that can go 245 miles per hour. I have three cars that can go 250 miles per hour. So I have to write 253 times. I have two cars that can go 260 miles per hour. And then I have one car that can go 270. Sorry, I know I kind of went off the page over here. So after I put my data set in order from least to greatest, I want to find the median. So from last week, remember the median is that middle number. So when I find the median, I want to cross out. So 220 goes with 270, 230 goes with 260, 230 goes with 260, 240 goes with 250, 240 goes with 250, and now my median is right here in between 245 and 250. So from last week, we said if the median falls in between two numbers, one way, if you can't think of what the average is just by looking at the two numbers, one way of finding the average between the two numbers would be to add these two numbers together. So 245 plus 250 is, 495. And then taking 495 and cutting it in half by dividing it by 2 to get 247.5. So that's my median of my data set. My third step is to find the lower quartile. So that's new to us this week. And what the lower quartile is it's the median of the lower half. So the lower quartile is also abbreviated by saying Q1, and that is the median of my lower half. So here's the median of the whole thing. So in this part right here, my lower quartile is the middle number between 220 and 245. So 220 goes with 245, 230 goes with 240, 230 goes with 240. So right here is my lower quartile, my Q1. So I got to find the average between 230 and 240 and then cut that in half. So 230 and 240 equals 470, and 470 cut in half is 235. Oh. Now, if you can see that 235 is the middle number just because you know it is, that's absolutely fine as well. I'm just showing you in case you don't see that 235 is the middle number between 230 and 240, what you can do to make sure you find the average correctly. Then I need to find the average of the upper quartile. So now my upper quartile is going to be between my larger numbers. So it's the middle number of my top half. So from 250 to 270, what's my middle number? So 250 goes with 270, 250 goes with 260, 250, 260. So right here, I'm going to draw a line and say that's my Q3. That's my upper quartile. I know it's in the middle because I've got three numbers to the left and then I've got three numbers to the right. So now my upper quartile is going to be, it's the median of my upper half, and that is going to be 255. So my upper quartile is then going to be 255, and that can be abbreviated by saying Q3. Now I'm finally at the part where I can find my interquartile range, and I do that by taking the difference between the upper and lower quartile. So the interquartile range is the difference between my upper half and my lower half. So my upper half was 255 and my lower half was 235. So when I take the difference between 255 and 235, I am going to get 20. So my interquartile range in this example is going to be 20. And they're talking about speeds of cars. So my interquartile range for this example would be 20 miles per hour. And that basically represents the data that falls between the lower quartile here and the upper quartile here. So the interquartile range means that half of my data is spread out, the middle half of my data is spread out by 20 miles per hour.